Alrighty, guys, good morning. So welcome to our first lecture here in California Honors. I'm glad to see that I think pretty much everybody is here. Yeah. Alrighty. So we're going to go ahead and do the normal first day things today. I'm going to go over the syllabus with you. We're going to talk a little bit about your responsibilities in the course, how I run things. And then we are going to get into a little bit of mathematics today. But let me just first show you sort of the very basics of how we're going to run stuff. I do appreciate you turning your cameras on. Just a quick heads up at the very start. Cams on is great. I love to see your face, get to know you, all of that. Just one thing to be aware of, I do record all of these lectures. They do go up onto YouTube after the fact. So just be mindful of your clothing, surroundings, all of that stuff. But yeah, it's wonderful to see you guys. All right, here we go. So this is what class is going to look like for the most part. This is the document camera that I use to transcribe notes. Everything that I put here on the dot cam needs to go into your notes. So you really want to take good notes in this class. As you work the homework problems, the notes are going to be your #1 resource to turn to look at a similar example or to see how to apply a certain theorem. Every day I will come over here and write MAC2311.0H1 this is section OH1. That's your section number. It's the honors section. Of course, California honors. And then the date today is 8/23/21. All right. The stuff that we're going to do today is the normal first day stuff. Which includes things like going over the syllabus, introducing you to the online stuff you'll need to use, namely Canvas and WebAssign. And we're going to talk a little bit about class policies. And then we are going to begin the mathematics itself. Which is in chapter 2. We'll look at a little bit of 2.1 and 2.2 today. All right, but first we're going to go over the syllabus and do all the normal first day stuff. I'll ask you try not to fall asleep during that. I have to grab that kettle off the stove really quick. I gotta go get some.
Excuse me, I have a question. Because I already bought the food at the end of last semester, and the ISBN is different from the.
I did get your email about that. Yeah, we'll take a close look at that. I was going to reply to that this morning. I just haven't had time. So there are a few different ISBNs for the textbook because there are different versions of the book that split up like Calc 1 and 2 from Calc 3. So I will take a look at the ISBN you sent me and check if that is going to be okay. As long as it is an early Transcendentals version of the 8th edition of Stewart, you'll be fine. So let's get into it then, and we'll cover the textbook conversation as we go through the syllabus stuff. So the syllabus for this course you can find on our Canvas page. Everybody should have been loaded into the Canvas course on Saturday. And then later in the day on Saturday, I published this. Obviously, my name is John Filesticker. We've all met because we did the honors interview process. You can just call me John or JP or Professor Faust, whatever you're comfortable with. If you want to pronounce the last name, it's like File Sticker. Class meetings are Monday, Wednesday, and we don't meet on Fridays. Oh, we do meet on Fridays. Yeah, Monday, Wednesday, and Friday. Yep. From 10:30 to 12. Sorry, from 11 to 12:15. Office hours are going to be Monday, Wednesday, Friday from 1 to 2 p.m. and these are in Zoom. So you can just click this link and it'll bring you into a waiting room for the Zoom office hour. We can also meet outside this time. Just let me know. So I keep like 10 hours a week free to do office hours. Only 3 of them are prescribed here. I may add a Tuesday, Thursday office hour, or I may keep the other ones all open for appointments, depending on what people want and what fits their schedule. So if you can't come to these office hours, send me an email or a Canvas message letting me know what times you could come to, and that'll help me decide when and where to add extra office hours. Something I'd like everybody to do right now is go ahead and get out your cell phone and put this date in there. So your final exam is December 8th, 2021, 12/8, and it starts at 10:30. So it's a little bit earlier than our normal class meeting time. I don't want anybody to lose time on the final because they show up at 11 thinking that's when the test is. December 8th is a Wednesday. So it is a day that we would normally have class, even though the last day of class is going to be the Friday the 3rd. So we won't see each other on the 6th, but we will see each other on the 8th for the final. And I would recommend a few notifications, like one the night before around 9 p.m. to remind yourself to get some good sleep, and then one with an alarm at like 7 a.m. to make sure you get up and get ready. Okay, other things here on this homepage in Canvas that I'd like to take a quick look at. Tutoring. Santa Fe does have online and in-person tutoring running right now. The online tutoring is pretty good. The way you get there, you can follow this link. They've changed this. Let's see. Yeah, I just got to take out the index. It's not HTML anymore. I'll fix that link. Okay, so you can follow that link. It will take you here, and then you can scroll down all the way down here to math and statistics, and they have the days and times that different things are available. So if you want to go actually physically to the library and get help with a problem in person with a tutor, you can do it in any of these days and times listed under the in-person hours. And then if you're outside those hours, or you just don't want to go to campus anytime during these days and times, you can follow the link up here to the Learning Commons Canvas page. Follow this button to Math, Science, and Business Tutoring. And then click this guy right here. And this will dump you into a kind of waiting room where you'll tell someone, hey, I'm in Calc 1, or I'm in Pre-Calc, or I'm in Calc 2. And they'll match you up with a tutor who can help you with your subject. So I definitely recommend taking advantage of the tutoring. I can specifically recommend Alejandro. He is great if you're having a hard time matching with a tutor that you think is like strong enough in your area, or having a hard time finding a tutor that you think communicates things clearly. I found that Alejandro, who still works there as far as I know, is a badass when it comes to the math and is also really good at communicating the ideas. So he's a good dude. If you have a particularly good experience with a tutor, I would love to hear about that. If you have a particularly bad experience with a tutor, I want to hear about that too, because I'm trying to work with the Learning Commons to tighten up a little bit and make sure all of our tutors are as badass as they should be. Moving on from there. Something else I need everybody to do today is to get into WebAssign. So you can click this link. You don't have to do it just this second, but sometime today, click this link. Come over here to enter class key, or if you already have an account with them, you can sign in and register for a separate class. And then if you follow the other link right there, this one, which says click here for the full course syllabus, download and save this document somewhere on your computer. All right, this is our class. It's MAC2311 Honors, Fall 2021. Your section is OH1. It's my name. I'm an assistant professor here at Santa Fe. I've been here for about 5 years. Before this, I taught at UF. Before that, I taught at UCF for a little bit. Love teaching math. It's a lot of fun. I'll give you a little bit more of my background as we go on if you want it. My office is A031D. That's downstairs in building A on the Northwest campus. That's the main campus. My email is my first name dot my last name at sfcollege.edu. You can just click the link in the syllabus, but definitely the best way to get a hold of me is a Canvas message. So emails, Canvas messages, they all go to the same place. But the Canvas message will tell me like what class you're in, what section you're in, everything right away. So I would prefer a Canvas message, but if you want to email me directly, you can do that too. This phone number rings in my office, which is not super duper useful because I'm not in my office. But I do go up there and check the voicemail like once a month. So if you need to get a hold of me, I recommend a Canvas message. You can call this. During daytime hours, I have it set up to forward to my home phone number, so I will be able to answer this as long as I'm not busy doing something else. Class meetings, obviously, you know, you're here. Office hours, like we said, Monday, Wednesday, Friday, 1 to 2 p.m. or by appointment. Final exams, December 8th at 10:30 a.m. The textbook, right? So this is what we want to talk about with EPING. The textbook is Stewart's Calculus, 8th edition, and it has to be the early transcendentals version. The ISBN I have here is the ISBN I got from the college for this book. I think it's the same as the ISBN on my book, even though mine is a teacher's edition. Let me see. Nope, slightly different. Yeah, student ISBN 9781285741550. Yeah, so this is the ISBN that, as I understand it, is the ISBN for the full version of the book, which looks like this, but without the red bar at the bottom. This has Calc 1, Calc 2, and Calc 3 all in a single book. Now, there are other versions that just have Calc 1 and Calc 2, and then Calc 3 is separate. They split them as single variable and multivariable. So maybe the one that you found, EPING, was a single variable only version. But as long as it is the 8th edition and it is early transcendentals, the early transcendentals matters more than the 8th edition. 7th edition, 6th edition, they're pretty much the same. But there are two versions of each. There's an early transcendentals and a late transcendentals version of each book. The late transcendentals, they don't introduce exponential functions and trig functions until the very end because they define them in terms of calculus operations. I am assuming that you guys know what exponential functions and trig functions and logarithm functions are, and we want to be working with them right from the very start of the course. So we need the early transcendentals version. I'll take a look at the ISBN you sent me and make sure everything is okay. I'll get back to you a little bit later today with that email, but I suspect as long as it's an early transcendentals 8th edition that you'll be fine.
Thank you. And also I have a question for the emails. You talk about Canvas message. Is the inbox it's not an email? Yeah. So you will check inbox more often than the email, right?
Well, actually, the way I do it, everything gets forwarded to the same place. So everything goes here, whether it's a Canvas message or a direct email, they all come forwarded to my email address. So I check them with the same frequency, but the Canvas messages kind of pre-format the subject line in a way that makes it easier for me to know which message came from who. So sometimes in my regular email, I'll get, students will email me from their Gmail account and not mention what class they're in. And then I have to, before I can help them, figure out, who they are and what class they're in. Using the Canvas inbox feature gets around that. It just lets me know immediately exactly who you are and exactly what class you're in. So I prefer that. But either one is fine. And they both come to the same place. They both come to my regular inbox in Outlook.
Okay.
Alrighty. So as far as materials that you need to purchase, you don't need to purchase a textbook. If you want to, you're welcome to. I also have an electronic copy of the textbook here, a PDF that I'm generally pretty happy to share. So don't stress about buying a physical copy of the text unless you really want one. I think having one is nice, but it's not required. What I do need you guys to buy is a WebAssign access code. So this is kind of like the proof of purchase for WebAssign that allows you to get in and work the homework problems, which will be posted in WebAssign, and also the study guide problems, which will be posted in WebAssign. Even if you don't have an access code yet, maybe you ordered it and it's on its way, or you're waiting for financial aid to come, anything like that, you can still register for the class. So access code or none, follow the link to WebAssign over here, then go to enter class key, and then put in this class key. This is the unique identifier for our class. I'll triple check that I updated that. I think I did. I was worried about that. No, if we give them the wrong one, class key. Yeah, 4451, right? 4451, yep. Okay, so go to WebAssign, register for our class using this class key. If you have your access code, then you can put that in as well. They will, after you put in the class key, they will ask you for an access code and some other personal information. If you don't have your access code, when you get to that page where it asks for your access code, scroll down a little bit and look for a link that says use temporary access or use trial access. That will get you through the first few weeks of class. After a couple weeks, if you haven't put in an access code, it will kick you out. And you really don't want that to happen because then you'll fall behind on the homework. So make sure sometime in the next 2 weeks, you get your hands on an access code. You can get them at the bookstore. You can also buy them directly from Cengage online. I'm not sure what's cheapest right now. It used to be cheapest to get them direct from Cengage, but I know if you want to use financial aid, then you have to go through the bookstore. But make sure you get an access code sometime soon. If you're having trouble getting one, like money is an issue finding it, or having somewhere in stock is an issue, or anything like that. If you have any issues getting your WebAssign access code, send me a Canvas message. I can work with you to find a reasonable solution. Calculators. There's only one calculator that you're allowed to use in this course, and that's the TI-32XS. Specifically on the tests, that's the only calculator you're allowed to use. As you work through the homework, if you want to use other calculators or you want to use Desmos, I don't have a problem with that. I'll use Desmos a lot here in class. I think it's a great way to look at a bunch of examples and try to get a general feel. Graphing functions, when we don't have the information, we need to graph them by hand. All of that is great. But as you solve the homework problems, make sure you're able to do that without anything more powerful than this. Because on the tests, this is all you're allowed. I'll tell you right now, you do not need a calculator for this class. You can get through this class just fine without a calculator. But I know a lot of people are a little bit nervous about arithmetic, things like that. I understand. So if you want a calculator, this is the one that you have to get for this class. It's about $10, super duper cheap. And it's the only one that's allowed. So we will be checking before tests to make sure this is the only calculator you're using. Other physical materials you need for the class, obviously a computer. I advise you keep your web browser up to date, whether you're using Firefox, Chrome, Safari, whatever. If it asks to run an update, let it run the update. Because if you don't keep it up to date, sometimes there can be issues with the software we use, like WebAssign, Canvas, HonorLock. All of those will assume that your browser is up to date. You also need consistent internet access, and this is an issue that I understand we don't always have direct control over. Last year, I had to file a complaint with the FCC in order to get them to fix some issues in my neighborhood, but I always keep my cell phone here with a hotspot as a backup in case my internet does go out or stops acting like it should. I advise you to have a backup also. So maybe your phone has a decent hotspot capability and reasonably fast connection, then you can use that for your backup. If not, then I suggest having somewhere else in mind, like a coffee shop or driving to campus is always an option. Make sure that, especially on test days, you have a backup for your internet in case it goes out at your apartment complex or something like that. Other things we'll need a functioning webcam. So your internet access needs to be sufficiently fast that you can stream video to me. I need to be able to see your webcam on those test days, and obviously for Zoom. The exam proctoring, the way I do it's a little bit complicated, so you'll have to use HonorLock, which will use your webcam on your computer. You'll also have to sign into Zoom on your phone, and I'm kind of picky about this. You're gonna have to set your phone up somewhere where I can see your work surface, your hands, your lap, everything like that, as an alternate view from the HonorLock view. HonorLock just shows me your face and your screen. Seeing your face is great. It's always nice to see what you guys are looking at, but really what I need to see are your hands, your lap, the location of hidden phones, tablets, that sort of shit. I'm going to talk more about cheating in a little bit. But yeah, so for the exam proctoring, you're going to need a smartphone with Zoom, and you're going to need your computer with your webcam, which means you'll need a total of 2 devices capable of streaming video. Okay. Course description, obviously this is Calc 1. It's the first in the 3-course sequence of calculus classes here at Santa Fe. The main focus in this course is to introduce the core concepts of calculus, which are limits, derivatives, how to take derivatives of fairly complicated functions using a bunch of different differentiation tricks. We're going to talk about some applications of the derivative to the real world. So you'd be surprised all the little places your brain will start doing calculus after you finish this class. It's really cool. Then we're going to talk about something called integrals, which are about finding areas. Once we get through the basics of what an integral is, I'm going to teach you some tricks for calculating integrals, how to find areas between curves, stuff like that. Because this is an honors class, along the way, I will be proving theorems. We won't just be using them. We're going to work a little bit with the nuts and bolts stuff, but we're going to also look considerably deeper at the machinery underneath it. The cell phone policy isn't super relevant here because obviously we're not in class together, but I'll just ask that you don't distract other people. So there's a Discord for this class. I'll ask that we kind of keep the Discord quiet during lectures. There's obviously the chat function here in Zoom, and I'll ask that we keep that focused on stuff that's relevant to class. Oh, I do see a message from David there in chat now that I'm looking, saying the class key is invalid. Has anybody else had that problem? I did just double check the class key. That's 713844551. Make sure you didn't copy paste the space at the end. It might be saying the space or the period. If that got in there, that's invalid, but just triple checking it here. It is correct.
And also, can I leave my handphone to the classmates? Because out of the class, maybe we need to make a group or for studying another time.
Yep, that's fine. And I don't know if I posted it for you guys. I will be posting a Discord server for you guys. So it's a nice way for everybody to talk, share information as needed. Let's see, do I have yours up yet? Not yet. So a little later today, I'll post a link to a Discord server. This is my Calc 2 server for this semester. This is the differential equations one from the summer. You'll have a thing like that, which is a good place to exchange contact info, information, build study groups, that sort of thing. Okay. If you want to look at the official course objectives, you can follow that link. Here they list all the very specific things that we're going to do. In addition to some of these, under the limits and continuity section, of course, we're going to study the rigorous definition of a limit in terms of deltas and epsilons. I think I warned everybody about that during the honors interview. Moving on, attendance. I am going to take attendance every day using the logs here in Zoom. So I'll ask that when you sign into Zoom, you use the same name that you have on your Santa Fe ID card, because that's how I'm going to take attendance for financial aid purposes also. So your financial aid disperses only after I've marked you as having attended. In order to do that, I need to have you in here using your real name. So please, I know sometimes it defaults to like John's iPhone. Or something else. If you've used another pseudonym in Zoom, just make sure when you sign in for this class, you have your first and last name there in Zoom. There is no attendance component to the grade, but missing class is very, very detrimental. You do not want to miss these meetings. Makeup policies. So if you miss a homework, if a homework goes by and you're not happy with how much of it you got done, that's okay. Just go ahead and submit an extension request in WebAssign. 99% of the time, I'll grant it without any question. I'll give you an extra 2 days or an extra week or something. If you miss a test, that's a little bit more serious. So if you expect you're going to miss a test, like you're traveling or you have something complicated going on in your life, you need to let me know ahead of time. If you miss a test for some reason that is not known to you ahead of time, reach out to me immediately, say, hey, I missed this test. And as long as it's not, honest, I've never denied somebody the opportunity to take a makeup test. So for whatever reason, you miss a test, just let me know quickly, and we'll get your makeup scheduled, but it has to be within 1 week. So if you wait 6 days to schedule the makeup, say, hey, I missed test 2, but it was 6 days ago, I'll say, sure, you can take a makeup, but we got to do it today. If you wait 7 days, then there's nothing I can do. So got to be done within 1 week. And then finally, no graded materials are taken after the day of the final. So the last day you can submit anything for a grade, makeups, whatever is the final. Homework and study guides. So every week there's going to be at least one homework set. Usually it'll open on Monday and be due the following Monday at the start of class. Some weeks, if there's material that I really need you to make sure you get started on right away, I might have 2 homework sets. The first due on Wednesday, and then the next due the following Monday. But for the most part, you're going to have 1 homework set per week, and it will be due at the start of class the following Monday. Also, before each test, I'm going to publish what I call a study guide, which is a shorter homework set that just has a few very important problems. And those will also go up in WebAssign. You need to complete them there. But the way you get the grade for the study guide is by writing out the solutions to your problems as you solve them, scanning those solutions, and then submitting them to Canvas. So the grades for the study guide come from your written solutions submitted to Canvas. I recommend that you talk about the study guide problems with each other, ask questions, share your solutions, bounce ideas off of each other, bounce ideas off of me, and then submit the written work as soon as you can. The last day you can turn in the written work for the study guides is on the day of the test. But if you submit them sooner, like even the day before, I will go in and mark them for you and say on a test, this would be, 3 out of 5 points, or on a test, I would take off a half point here, or on a test, this would be perfect. I'll grade those problems like I would grade them on a test. And that way there are no surprises when the exam comes. You know exactly what I expect from you in terms of legibility and organization, completeness, all of that. So the homework every week, there's going to be one due at the start of class each week, maybe one due in the middle of class. I'll let you know any weeks we're doing that. And then the study guides, you'll have them at least 1 week before the test. You should write out your solutions and submit those solutions to Canvas as quickly as you can. I will give you feedback on your written work, and you're welcome to discuss those with other people, including myself. And that is it. Lab meetings, Fridays are officially lab meetings. Right now, with everything remote, it's kind of hard to do these the way I like to. So ideally, I would have you guys on most lab days going up to the board and presenting solutions to homework problems. And then those, I would usually offer you some extra credit bonus points on the next midterm. Very hard to do that. I've tried a few bits of software for that in the online setting. It's not working especially well. So for now, most lab periods, we'll focus on problem solving, but just think of them like an extra class. It's just another day of lecture. Some days I will have you do some lab type projects where you're playing around in Desmos or Maple, but just think of this as a Monday, Wednesday, Friday class.
For the homework, can you post earlier about 1 week for the next class homework? Because I have 2 jobs. If I have a time, so I can finish it earlier, so that I don't need to always think about my homework. I'm afraid to due date, the deadline. And for the study guides, is it the same with quiz?
So we don't have quizzes. We just have the homework, study guides, and tests. The homework, let's see. So I like to cater the homework to each class. So I have a few different Calc 1 classes, and I like to have a separate problem set for each class where I choose the problems based on the things that you guys seem to struggle with or need extra practice with, things like that. So it's a little tough for me to release them very early. I can say I'll get them out as soon as I can, but the general rule, because I need to see how you guys understood the last set before I create the next one, the earliest I could get them out is maybe Sunday. So I can try to get the homeworks out like a day early, but I don't think I could get them out a week early because I choose the problems based on how you guys handle the previous set. But if you need more time or if you're having trouble with the scheduling, we can try to work something out a little bit separate where maybe you have a little bit of extra time to accommodate your work schedule or something like that.
I need to work on the weekends, Saturday and Sunday. If you only create earlier about 1 day, for me still a little difficult.
I'm not sure what to do there, honestly, because I do feel it's important to choose the homework problems to suit you guys individually. It's kind of impossible for me to do that a week ahead of time until I see how you did on the last homework set. Let me think about what I can do there. I'll tell you, I don't have a way to comply with that off the top of my head, but I'll think about it and try to find a solution. And in the meantime, if you end up needing more time for something, I can always extend it later, but it's hard for me to do it earlier because until I see what you did on the last homework, I don't know what you need on the next homework.
Okay, thank you so much.
Yeah, we'll figure something out. That brings us to the exams. So there's 3 midterms and 1 final. The midterms are going to take place during class time here. And like I said earlier, they'll be proctored with a combination of HonorLock and Zoom. So you'll need to sign into Zoom on your phone. I'll post a link just like a regular class link saying, sign on your phone with this. I will ask you to set your phone up kind of on the side or somewhere off over here or leaned up against a coffee cup or something like that, where I can see your desk, your hands, your work surface, your lap, all of those things. And then once you get the okay from me on how your Zoom phone situation is, you can sign into HonorLock and begin the test. If you don't want to deal with any of that, the other option is to take the tests in the testing center, where there will be someone there to physically proctor you in person. But there's 3 midterms and 1 final. The midterms all happen during class time, and the final is on the 8th at 10:30. The final is cumulative, covers everything from the whole semester. The midterms just cover the material from that chunk of class. So exam 2 isn't going to explicitly test you on exam 1 material, but it is the nature of math that these things build. So yeah, that's it. 3 midterms, they're not cumulative. 1 final, which is cumulative. And the midterms happen in class, proctored with a combination of HonorLock and Zoom. The recording notice, we kind of already went over this. I do record all the class meetings here and I post them to YouTube after the fact, so you guys can rewatch them, fill out your notes, anything like that. This means that if your camera is on, you'll be a part of that recording. So just be mindful of your dress and your surroundings. Daniel asks, if we want to schedule the exam, like in the testing center, how do we do that? Or do we have to do that ahead of time? So if you would rather take the exam in the testing center than deal with all of my stringent proctoring things, just let me know in the week leading up to the test and I will schedule it for you there. So they need to know to expect you. Just let me know that you would rather take it in the testing center and I'll make all those arrangements for you. Okay, that brings us to the first kind of special thing for the honors class, and we talked about this in the interviews. So you have to do an honors project for this class. It's one of the things that makes the honors class special. The honors project is like a deep research paper where you pick some math topic. It really is wide open, any math topic that you want, and you spend the semester reading and learning about it. By the end of the semester, you're expected to have produced a pretty nice research paper. There's no word limit or anything like that, but I'll be checking in with you a few times over the semester, making sure that things are coming along well. The paper should be focused on the mathematics. So whatever it is you choose to do, if you choose to write a paper about a famous mathematician, or you want to do one of the kind of canned projects in the textbook, or you want to do your own thing, you have to let me know before the end of next week what your topic is going to be. And then in the next few weeks, we will schedule a few different times for me to check in with you over the semester. So we're going to have 2 check-ins during the semester where you will show me how your paper is coming along. We'll plan those ahead of time. They won't be surprises. And then at the end of the term, you're going to submit to me your paper. After the class is over, we're going to have a special meeting where you guys present your honors project. And we usually invite all the other math faculty, any students from the math team who want to take part in that, to come and listen to the presentations. That presentation is going to be you basically going through the content of your paper, but you want to have some visual aid to back you up, like a slideshow. Most people are doing PowerPoints or TIC slideshows. Beamer is also acceptable, whatever you like to use for those sort of presentations. So you'll need to write the paper, right? Pick your topic, obviously, get the topic okayed by me, and then write your paper. After you've got your paper all set up, you're going to make a slideshow or some sort of presentation. You can do live demos, you can have videos, you can just have a straight PowerPoint, doesn't matter, whatever you like. And then at the very end of the semester, after we've finished everything else, we'll have a special meeting where you guys get up and present your honors project. If you're especially proud of your project, I strongly recommend entering it in the RU fair. That's the Research and Undergraduate Education Fair. If you're going to do that, you need to also make kind of a science fair project board for it, where you just outline the basics, the topic, a little bit of background, and then the core of it, the mathematics, and a little bit kind of where that mathematics is going in the future.
How do I find this RUE Research Undergraduate Education Fair?
So I think if we just Google, we should find something. Yeah, the RU Festival. And here's some information about the 2021 one. Now, I think this was, yeah, last spring. But you see here, you can take a look at some of the projects that people have done. And the general information is here. So I can paste these into the chat. You guys can save those links. The Roo Fair or Roo Festival is a nice opportunity to meet other people who are interested in similar things. It's a good opportunity for you to network with other faculty, professors, researchers in your area.
Is it when we speech, after speech, you will post our speech in the YouTube, and also you can give the record to us and send it to the Roof Fair.
So I can't submit your project to the Roo Fair for you. If you want to submit to the Roo Fair, that's something that you have to do on your own. If you wanted, I could record your presentation and you could use that as a part of your submission at the Roo Fair. But that would be something you'd want to tell me ahead of time. So if you know that you want to enter your project into the Roo Fair, before you give your presentation, let me know and I'll record it, and then I'll give you a copy of that recording, which you can use as a part of your presentation at Roo. But in addition to those networking opportunities, letting you meet other people who are interested in your stuff, faculty who do research in that area, there are also cash prizes and scholarships. So it is a really nice thing. Looks good on transfer applications, stuff like that.
Thank you so much. And also I already sent the topics to you. I'm not sure, could you accept this topic?
I'll have to take a look and let you know. So I need to know your topic before the end of next week. That's the thing. So if you're having trouble thinking of a topic, definitely send me an email or come by office hours and chat about it. And once you think you know what topic you want, please again send me a message, Canvas message or email, and I'll file that away. After you have picked your topic and gotten the thumbs up from me to continue with that, then I'll ask you to schedule those 2 check-ins. So the 2 times in the semester where I can take a look at your paper, maybe help you with the mathematics if it's necessary, suggest some edits or changes, and then that'll be it. Things people have done in the past. I think last semester I had someone talk about Sophie Germain and her work on Fermat's last theorem. I had one person do the shape of a can project in a great amount of detail. So this is a project that's outlined in the textbook. But then he went a great deal further and talked about the history of manufacturing and different kinds of optimization methods that have been used in industrial engineering. So pick something that's interesting to you, something you want to read about. And then let me know what you're thinking and I'll tell you, yeah, that's great, or maybe we should change it a little bit to this. But 9 times out of 10, I'll just give you the okay. I think we've talked about the honors project enough here today. If you do have any questions about the honors project, sort of what should be in your paper or how much depth is expected, please don't hesitate to ask. Don't get started without knowing for sure that what you're doing is good. So if you have any doubts or uncertainty, please come to me. One of the other things that makes this class special is the student teaching component. Again, we talked about that during the interview. So before the end of the second week, I also need to know which section you would like to student teach. So everybody here is going to have to deliver a lecture at some point in the semester. These are the sections that I recommend. I recommend picking one of these. Now, I think we probably have more students here than we have sections here. I'm not 100% sure where we ended up in this class, but you're allowed to work in pairs if you would like also. This is a first come, first serve thing. So, if Radha tells me I really want to do section 2.6 on limits and continuity, and she tells me that today, and then Sarah were to tell me next week that she really wants to do 2.6, I would say, well, Radha already asked for that one. So either you can work with her or you have to find another section. So I recommend talking to each other, see if any of you want to co-teach one of these sections, and pick a section or 2, right? Have like, the one you really want to do and also a backup, just in case somebody else already got yours. But just like the honors project topics, I need to know from you by the end of next week, which one of these sections you would like to student teach.
Excuse me, if I teach the sections, will you still teach that session again?
No.
Or only student?
Yeah, so the student teaching is a big responsibility. You guys will be the sole individual responsible for delivering that content. Now, the way this works is about a week before your student teaching day, You're going to come to an office hour with me, and we're going to go over your lesson in great detail. We're going to go over all the examples that you want to do. We're going to go over all the theorems, how you're going to present them, the notation. So nobody's going to be getting up there and just doing it for the first time on that day. So you need to let me know by the end of the second week which section you want to student teach, and if you're going to do it with somebody else or not. And the other thing we need to do on that day is schedule your practice run. So we're going to meet about a week before your actual student teaching day for a practice run. And if there's anything that I would like you to change, I'll make those comments then. If there's anything I want you to add or remove, I'll let you know. For these reasons, I don't recommend putting together one big YouTube video. So the options for student teaching, you can do those lectures the way I do on a document camera here. There's software for your phone that'll allow you to do that. I've had students use their iPhone or Android kind of sitting on top of a ledge, just pointing down at a paper like this so they can deliver a lecture live. And that's great. I think that's a really nice way to do it. If the idea of doing a live lecture makes you nervous, I totally understand, don't stress. You can also pre-record a YouTube video. Or my suggestion, several short YouTube videos, like 4 or 5-minute videos, something like that. 5 to 10-minute videos would be good. Because if when we meet to do our dry run, there's something that needs to change, like you made a little mistake, or I want you to add something, or I feel like something needs to be removed, I don't want you to have to re-record the whole thing. So pick your topic soon. The sooner you let me know, the more likely you get the topic you want. And then within about 2 weeks of us getting to that section, kind of as soon as you're comfortable, read ahead into that section in the textbook and start developing your lectures. Then 1 week before your student teaching day, we will have a meeting where you will do a dry run. You will run through your lecture for me, and I will let you know if there's anything that we want to change or add or remove. And the format is entirely up to you. The two that I've found work very well are the live lecture with a document camera or a combination of several short YouTube videos. Either one is fine. All right, any questions on the honors project or student teaching?
Quick question.
Yeah.
So regarding when we're delving into the mathematics, I've never done a paper of this kind before. So what exactly are we just following what their process was when they were first discovering it, or are we delving into practical uses of those mathematics? What's the angle?
All of those things, or any of those things. So you are free to explore the math topic however you want. I do have here, I think, some examples that I can share with you. Let's see, journal articles. Yeah, so here are some examples. No, these are posters to advertise, syllabus timelines, project handout. Looks like I don't have any. Oh yeah, here we go. Samples of honors media presentations, image processing, presentation. So let me send you these things. Here are, I'll put this in the chat. That last one I'm gonna have to fix. Oh no, I got it. Anyone else? Okay. So each of those is a presentation, an honors presentation from an honors class of the past. And I encourage you to take a look at those to sort of get an idea for the content. You can focus solely on the mathematics that a particular individual did, or you can explore a topic. So like I've had people talk about, you won't be able to get to that. I've had people talk about Newton and Leibniz, the discovery of calculus and kind of their feud that went on. in that setting, the person talked about how Newton arrived at his idea of fluxions and how Leibniz simultaneously arrived at his corresponding notion that we call the derivative. They talked about how the mathematics was developed, sort of the ideas that came before that inspired them, the particular big steps that each person took, and then how they were used in the future to basically develop the Industrial Revolution. So something like that would be fine. It really depends on your topic. I had one person last semester do an honors project on the physics of Mortal Kombat 11, right, the video game. And she took a frame-by-frame analysis of a few different fights in Mortal Kombat 11 to try and determine whether the gravitational forces in the game were realistic, to try and determine like the accelerations and forces behind each punch or kick or whatever it was, you know, combat maneuver. There's a lot of different ways you can go here. The big thing is that you focus on mathematics. So the majority of the paper should be a discussion of specific mathematical tools or methods or ideas. And then however you want to flesh that out really depends on the specific topic you choose. But you can look at those samples I sent you of the presentations as a sort of guide to how much time should be spent on biographic information, how much time should be spent on raw mathematical content, how much time should be spent on examples, that sort of thing.
You send the IP to the chat, but I don't think the chat is make it chaos.
Yeah, I see that the formatting has messed up a little bit, but if you copy paste, you should just take this thing here, copy paste it into a text document. And then you can fix the formatting just by fixing the spacing. So I don't think I can get it to paste with the formatting. So yeah, I do apologize for the formatting being annoying like that, but if you come in here and fiddle with it, you'll be able to pull out the URLs. And there we go. I think that's approximate spacing. Right. Calculate one in mathematics. Oh no, that's a part of this. All right, I'll try pasting it like this and see if the formatting sticks. The honors projects are pretty much the same for Calc 1, Calc 2, Calc 3 differential equations. The rules are the same. The content will of course be different because a differential equation student has, you know, more background than a Calc 1 student does. We don't have any sample honors projects from Calc 1 saved. So don't use that as a guideline for specific mathematical content. Use it as a guideline for like formatting and how much time you should spend on math versus other stuff. The project doesn't have to be Calc 1 specific, right? Like the Mortal Kombat thing was pretty Calc 1 specific, but I had another student do an honors project on the Library of Babel from Borges' novel, asking whether it could exist or would implode into a black hole spontaneously. Obviously, the mathematics there is way beyond the scope of Calc 1. We've had other students do them on graph theory, on all sorts of different things, CMOS chips, ray tracing video cards. So it doesn't have to be a Calc 1 topic, just has to be a math topic. Any other questions about the honors project or student teaching?
I did have one for the student teaching.
Yeah, what's up?
So my only concern with it is because math is cumulative, picking a topic that's later down the line, how on earth are we supposed to understand it?
Yeah, it's a little intimidating. So first, I recommend reading ahead, right? Always a good idea to kind of leaf through the book and get a feel for what each section is about. Now, no matter how aggressive or independent you are, I don't expect anybody right now to be able to deliver a lecture on 6.1 because it has so much stuff that you've never heard of. But you can take a look at the section and see what sort of things are going on there and whether that's a topic that you think you would enjoy learning about. And then once we get a little bit closer, you can start preparing the lecture content. So I would say when we're about 3 or 4 sections behind the one you intend to teach, that's the moment to go read ahead and start preparing your notes. It will require some independent thinking. And that's one of the big challenges here, is that you have to move ahead of the class to develop your lecture. But you don't have to move ahead too much. If you were going to do 6.1, I wouldn't recommend starting on that until we talk about 5.1 at least. Alrighty, any other questions here?
Yeah, I had a question about the WebAssign stuff
Yeah, what's up?
really quickly. So for the key, is that just are that spaces? Are there no spaces for the key?
There are spaces between SF College and the first 4-digit string, and there's a space between the 2 4-digit strings. There should be no space afterwards. So if you copy it exactly like this, oh, it doesn't want to do it. Yeah, I guess when you copy, you'll have to delete the space at the end.
Okay, and so you just put that key in, and then
I'm sorry, can you say that again?
Is it a temporary key or is it like for the semester?
So the class key is just what tells WebAssign that you're in this class.
Okay.
And the access code is the thing that actually gives you permission to use WebAssign. So the class key is permanent. And then the access code, if you don't have one, you can use their temporary access.
Okay, yeah, so the access code is like what we bought, I guess, or were you supposed to buy earlier?
Exactly.
Okay, but there's a temporary one right now because, yeah, I don't have mine right now.
So there isn't a temporary access code, but when you get to the page that asks you for the access code, if you scroll down a little bit, you'll see a link there that says, click here to use temporary or trial access, and that will get you in for the first 2 weeks.
Yeah, I'll just do that. Okay.
Cool, cool.
When will you make sure about the ISBN to me? Because I want to get the book earlier.
I'll take a look today. Yeah, I got your email. I was replying to it this morning when I had to start my first class. So I'll take a look at that today and confirm for you whether that ISBN is okay or not.
Oh, yeah.
Thank you so much.
Okay, sorry. I had one last question too. Sorry.
Sure, no, go ahead.
This class is like virtual all the way, right? Like it's not a hybrid, it's virtual.
So it is what's called a hybrid class because we have a set meeting time and the exams take place during a certain time. So we meet every day at this time, or every Monday, Wednesday, Friday at this time in Zoom, and the exams have to be taken during class time. That's what it means to be a hybrid class.
Yeah, see, I thought we
but
had like
we don't ever have to meet in person.
Okay, yeah, that's all I want to know because I was confused, but okay.
I got you. Yeah, no problem. Yep, the hybrid designation just means we have a specific class meeting time, and that the exams have to be taken during a very narrow window rather than like a 3-day window like you have for fully online classes.
Okay.
All right, I'm going to go ahead and finish up the syllabus. So we've got some important dates here, the particular ones to pay attention to. The last day to drop the class and get your money back is the 27th. That's 4 days from today. The last day to drop the class without receiving a letter grade is the 2nd of November. That's the last day you can withdraw and get a W. If you stay in the class beyond then, you will get an A through F letter grade. If you're going to withdraw beyond that, you have to go through the petitions process. There are a few holidays here that you should take note of course. The last day of class for us is December 2nd. Your final exam is again on the 8th, and grades will be posted to East Santa Fe no later than the 14th of December. The breakdown for the grade in this class, the homework is worth about 7%. The study guides are worth about 12%. And remember, the way you get credit for the study guides is submitting your written work in Canvas. Completing the study guide in WebAssign does not get you this credit. You have to submit your written work. These are graded just for completeness, not for correctness. So don't cheat on these. Don't put in written work that comes from Mathway Photolab, whatever. I need that shit. Just give me your actual work there. The midterm exams are each worth 100 points, so it's about half the grade altogether. The final exam is 150 points, which is about a quarter of the grade. The honors project is worth 50 points, or about 8%, and the student teaching is not a large component of the grade, but it's not nothing, it's 5%. The grade scale that we use is the normal one. 90 to 100 is an A, 80 to 89 is a B, 70 to 79 is a C, and then the top 3% in each of those earn the plus designation. My rule as far as grade rounding is this: if you're within 1.5% of the next letter grade, I'll round you up. If you're more than 1.5% down, then I will not. So like, you know, an 89.5, that's definitely an A. A 67.8 is still a D. The next page here is all pretty boilerplate syllabus stuff, jellos. These are some statistics that I track throughout the semester. The state compiles those to make sure that we're doing a good job here. Has nothing to do with your grade. You may see a few little things on the test indicate like a jello. Don't worry about it. It doesn't mean anything from your angle. Academic integrity is a very big deal. It's important that you guys are honest, and in particular, do not cheat on the tests. I will talk more about that in just a second. But I recommend reading here so you know what sort of rules you're being held accountable to. The ADA, Americans with Disabilities Act, if you have any sort of disability, whether it's registered with the DRC or not, please let me know at the start of the term here, and I will work with you to accommodate those things. If, for example, my wife, she has adult ADD, and so she works with the DRC to get a low distraction testing environment and a little bit of extra time on the exams. Anything at all. If you have vision problems, hearing problems, focus problems, any stuff like that, you can let me know. It's 100% confidential. And regardless of whether you're registered with the DRC, I'll work to accommodate you. Similarly, under accessibility, all the material for this class is published in an ADA compliant fashion, PDFs all marked up in LaTeX, works well with screen readers. Everything in Canvas should work well with screen readers. If you're having problems, again, hearing, seeing, or getting any of the media for this class to work for you in a way that you can consume it, just let me know and we will find a way to make things work well. Discrimination and harassment, this should go without saying, but don't harass your classmates. Don't harass me or other employees of the college. Please just be kind. You know, that's all. I will be kind to you. Please be kind to each other and to myself. Everything will be Gucci. But if you want to know the specific rules, they're linked here. Similarly, your rights and responsibilities are linked here also. So Santa Fe, we really do want to have this sort of community spirit. We want you guys to feel like you're a part of a good thing. And the way we do that is by pretty strictly enforcing these rules. Just like everything else, you should know what you're being held accountable for. So I recommend reading those. We get now to the extra note on cheating. I've got good stories and bad stories here. So bad stories first. Last fall, 1 year ago, in my Calc 2 class, on one exam, the final exam, I caught 9 people cheating, and they all failed the class, ZFs. Not just a regular F, but like an F and a middle finger. Don't cheat, right? Don't cheat. Over the summer, the largest single batch of cheaters I caught was on the 3rd exam in pre-calculus. I caught 6 people cheating on that test. I'm really good at catching cheating. I know not everybody is, right? I know that over the last year and a half, with everything being online, it's getting more and more tempting and more available. This idea of having an app on your phone or having something taped up behind you or having somebody else in the room. I've seen it all, I promise you. I have Symbolab, Photomath, Mathway, Wolfram, and Desmos all installed on my phone. I know exactly what the output from those things look like, and I run my own tests through every bit of cheating software I can find. I know exactly what comes out of those apps. I know what it looks like, and I also know what good work, honest work, looks like. I'm really good at spotting bullshit. Don't bullshit me. Even if I see something that I don't immediately recognize as known output from some particular cheating software, I have colleagues that I share that suspicious work with. And more than once, 2 of the 6 that I caught on exam 3 in pre-calculus over the summer, I knew something was up, but when I ran it through all the apps I knew, nothing matched. And then I sent it to one of my colleagues. She ran it through another app that I hadn't heard of. It matched perfectly, and those students both failed. Don't cheat. I'm really, really good at catching it, and I take it really, really seriously. I know it's possible that not all your previous math professors were like that. Some don't give a shit. Some care a little bit, but not enough to do anything about it. I care a lot. I really just want you guys to learn the material. That's what I care about more than anything else. So if a test is getting close and you're starting to have that little itch in your brain wondering what sort of apps you could use or where you could hide a phone or where you could tape something up or how you could have someone in the room, instead of doing any of that, please just email me. Just reach out to me and let me know that you're feeling desperate. I'm not going to think any less of you. I'm not going to cause you any trouble or strife, anything like that. If you reach out to me and say, hey, I'm starting to feel desperate, I'm starting to feel like this exam is going to be really bad, let me know. I'm happy to move the test for you. I always have students who, for whatever reason, can't take the test on that day, right? Either they're out of town or somebody's sick or something bad happened, flat tire, whatever. For one reason or another, I always have to do a makeup session for pretty much every midterm. And if you're in that situation where you're starting to think that you might be tempted to cheat, just let me know. And I will let you take the makeup test. It might be 5 days later, it might be a week later, but it'll give you some extra time to study. And I can also arrange some one-on-one office hours, some extra tutoring, some extra practice stuff, worksheets, whatever. I will work with you till the cows come home to help you get that material down in a way that you feel comfortable moving into the test. But if you cheat, and if I catch you, I will set you on fire and raise you up the tallest flagpole I can find. I'm really strict about this. It's not something that I have any sort of leniency on. So please just don't cheat. I will help you not need to cheat. Just communicate with me. Please, please, please don't cheat. And here's the course calendar. So this is about the pace at which we're going to go through things. We're going to this week do a little bit of algebra review. We're going to talk a little bit about the concept of tangents and velocities, average velocities, and we're going to move on to limits. In the second week, we're going to talk about limits in great detail. Specifically, we're going to cover sections 2.3 and 2.4. 2.4 is the delta epsilon definition of a limit. We'll also talk about what it means for a function to be continuous and what it means to take a limit as x goes to infinity. Moving on from there, we're going to start talking about things like rates of change and derivatives. That's our first big step in the calculus direction. And once we've gone through all the good derivative stuff, we will have our first test. Between the first test and second test, I'm going to teach you a bunch of tricks for calculating derivatives. So in addition to the basic differentiation rules, we're going to learn something called implicit differentiation, logarithmic differentiation. I'll show you some word problems called related rates, where you can see if two objects are changing and they're related to each other through some geometry or algebra, how to find one rate of change in terms of the other. We'll learn how to approximate functions really, really well using calculus, called linear approximation. We're going to learn how to find mins and maxes for functions, you know, those local maxes and local mins that you had to identify in pre-calc. We will now have a very clear way of finding not just those x values, but also those y values, even if you don't have the graph. And then we're going to talk about how the graphs of an original function relates to the graph of its derivative, a cool trick called L'Hopital's rule for calculating certain limits. And then we're going to learn how to sketch graphs of functions really, really well. And that will get us ready for exam 2. And then exam 3, everything between exam 2 and 3 is what's called integration theory. So we're going to step away from the derivative and we're going to learn about something called an antiderivative and how that relates to the problem of finding the area underneath a curve. So you can kind of think of it as like everything up to exam 1 is limits and continuity and basic differentiation rules. Everything between exam 1 and exam 2 is cool stuff you can do with the derivative, applications of the derivative. And then everything between exam 2 and exam 3 is solving the area problem. How do you find areas under a curve or areas between two curves, especially when the boundary is not straight, you know, and it's curvy. And that's pretty much the class, guys. So limits, continuity, basic derivative stuff, applications of the derivative and cool things you can do with it, and then finding areas of regions in the plane and evaluating integrals. That wraps up the syllabus. Do you guys have any questions for me before we move away?
Yeah, I have a quick question. So
Sure.
I was looking, back on WebAssign again, and I saw that we had like, so the course with a book, like an online book, is that like the whole book and all that?
Yes, it is.
Okay, yeah.
So you don't need to buy a physical copy of the book. When you get into WebAssign, there is an ebook and you can use that. If you would like a full copy of the book that you don't need to be online for, I do have this PDF, and as long as you don't tell anybody, I'm happy to send you a copy of it also. This is the whole book in PDF form.
I want the whole book for the PDF one. And if I get it, I think I can return my paper copy book.
Yeah, absolutely. Just send me an email letting me know that you would like the PDF and I'll send it to you. All right, but if anybody asks, it didn't come from me. Fell off a truck or something. Okay, all that said, I think it is time to do some mathematics. So I want to introduce a bit of notation and talk to you guys a little bit about the real number system in detail, because real numbers are underappreciated. So this is actually before we actually get into chapter 2. We're just going to talk about some preliminaries. First, a few different number systems. Richard Dedekind, who's a famous mathematician, one of the first guys to try and say for sure and in detail what real numbers even are, has this famous quote. He said, "God created the integers. Everything else is the work of man." I'm not sure I agree with him, but what he meant by that was you can start with the counting numbers. So when you see me put a bunch of things inside curly braces like this, in mathematics, we call that a set. So this is the set containing the numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, all of the positive whole numbers or non-negative whole numbers. 0 is kind of controversial here. This is called the natural numbers. They use the word natural because, you know, these show up very naturally in counting. It's possible to have 0 of something. It's possible to have 1 of something. I have 5 fingers on my hand. Anything that you can count like that is a natural number. And if I want to refer to this set as a single thing, I may use this notation, the Blackboard bold N for natural. If you want to include the positive and negative versions of all these things, then we're talking about the set called the integers. And the Blackboard bold notation for this set is a big Z with an extra bar here. That Z stands for the German word Zahlen, which is German for number. So the natural numbers are the counting numbers, and the integers are those, but together with the negative versions of those. 0 is, of course, neither negative nor positive. From here, we can build what are called the rational numbers. And I'm going to explain this notation to you. So this, first you see the curly braces here. That means the set containing all fractions of the form n over n, and then this vertical bar here is read as such that. And this symbol right here is an element of. So what we're saying here is this is the set of all things of the form m divided by n, such that m and n are both elements of the integers. So in other words, who can give me an example? What's an example of a number that is a part of this set?
3/4.
Sure, 3/4. Is negative 1/5 in this set?
Yes.
So if you had to describe this set in words, how would you describe it?
M over n, given that both m and n are integers.
Sure, yeah, good. In other words, it's all the fractions made up of integers, right? It's all the fractions where the top and bottom are both integers. The name for that is the rational numbers. So when you hear somebody say a certain number is irrational, what they mean is it's not an element of this set. The Blackboard bold for this is a Q.
And also I have a question, because I think natural number and the integers belong to rational number too.
I'm sorry, what? I couldn't quite hear what you said at the end.
I think the natural number and the integers belong to rational number.
They do, yeah, that's a neat fact, and we can make a note of that. It'll let me introduce subset notation. The set n is contained within the set Z, right? Every natural number is an integer, and both of those sets are contained within Q. So every natural number is also an integer. Every integer is also a rational number. Just take the denominator to be 1. And then there is a set beyond all of these. The real numbers. For which we use a Blackboard bold R. Now, how do you define the real numbers? That's actually a big problem. It's not obvious, right? Richard Dedekind, famous mathematician from the 18th century, was one of the first people to do it in a really rigorous way. But what I'm going to say here is that the real numbers, x is a real number if it has a decimal expansion. That decimal expansion doesn't need to be finite in length. It might be. It doesn't need to be repeating or non-repeating. It might be either of those. But the real numbers, in other words, this is the set of all numbers or all possible decimal numbers. And it's true that R is, Q is contained in R. And we can go a step further and talk about complex numbers. Complex numbers are kind of a two-dimensional version of the real numbers. But I'll leave those out of the discussion for now.
Can I say all real number is has rational number and the irrational number?
Yes, that is true. So the real numbers, another way you can think of this, and we have to say what does it mean to say all the numbers rational and irrational is a little bit unclear. But certainly this is all rational numbers unioned with all irrational numbers. Yep, that would be true. So what is an irrational number? It's a number that cannot be written as m over n, where m and n are both integers. So this can be a little bit cyclic if you're worried about the logic, but I think for an intuitive approach, it's perfectly reasonable. All right. One or two last little things before I let you go here today. The reason the real numbers are special, and in a slightly more grown-up math class, we would define the real numbers this way. They are the unique, complete, ordered field. Right, so each of these words means something very, very special. The word complete means there's no gaps. Right, like between 1 and 2, there's a gap. Right, there 1 and 2 are not right next to each other. There's a gap. The real numbers have no gaps. And what we mean by this is given any x and y such that x is not equal to y, there are other real numbers between them. And a neat fact is that there's actually infinitely many other numbers in between them. So complete means when you arrange these things in a line, the line is solid, no gaps at all, nothing missing. If you imagine, for example, the rational numbers, you could put those on a line also, but there is a gap at the square root of 2, right? There is no square root of 2, that is a rational number. So the real numbers are complete in the sense that when arranged in a line, that line is solid. Ordered. Ordered means can be arranged in a line. Right? The natural numbers are ordered. 5 is bigger than 4, 7 is bigger than 3, but there are lots of gaps, right? There's gaps between 4 and 5. There's gaps between 3 and 7. So complete and ordered means they can be arranged in a line, and when you do that, there are no gaps. If we want to speak in technical language, this means given any x different from y, either x is smaller than y or x is bigger than y. All right, and this is a special kind of order called a total order. There are other kinds of orders called partial orders that complex numbers satisfy, but real numbers don't. And a field, what is a field? Well, a field means given any x or y, real numbers, we can form x plus y, x minus y, x times y, and if y is non-zero, we can form x over y, and all of these are themselves real numbers. So a field is a special name in mathematics for a set of objects where you can do this algebra and get stuff that belongs to that set. So if I add 2 real numbers, I get another real number. If I multiply 2 numbers, 2 real numbers, I get another real number. If I divide 2 real numbers, I get another real number. A fun game to play is to see which of these things you cannot do in the other number systems. Like if I add 2 natural numbers, I do always get another natural number. But if I subtract 2 natural numbers, I don't always get another natural number. If I multiply 2 integers, I always get another integer. But if I divide 2 integers, I don't always get another integer. It turns out that one of the other sets I referred to there, N, Z, Q, one of them is a field, not just R. The real numbers are not the only field, but they are the only complete ordered field. So the completeness is the thing that's very special to calculus. Let me see how I'm doing with time now. All right, we are at time, so I am going to go ahead and stop here. Next time, we're going to talk a little bit about the topology of the real line. So open sets, closed sets, what it means to be open or closed. And then we're going to start talking about graphs of functions, rates of change, things like that. Is there anything you guys would like to ask before we wrap up for the day?
Could you post this video earlier in the Canvas?
Yeah,
Because I want to review it again.
Sure, of course, yeah. I have to upload 3 other videos from this morning, so you guys are third in the stack of things to be posted, but they'll all be up within an hour.
A question about complete.
Yeah.
I'm trying to figure out something is a real number if it has no gaps or if it has gaps, because every real number that I can think of will have those gaps.
So we're not talking about a real number. We're talking about the set of all real numbers. So if I think of the set of all real numbers arranged in a line, maybe 0 is here, wherever you throw a dart, no matter where you hit, or yeah, throw a dart. Wherever we throw a dart, we will hit a real number.
I have to go now, thank you.
Yep, and if we were just looking at the integers there, for example, you can imagine I could miss lots of stuff, right? Like here's 1, here's 2, here's 3. If I throw a dart, there's no guarantee that I'll hit an integer, but I will always hit a real number. So the integers are not complete. There are gaps between the integers, but the reals are complete. There are no gaps. Alrighty, any other questions
Thank
before I let you guys go? Okay, then I'm gonna go ahead and end the meeting here. I'll see you guys all back on Wednesday.
Thank you. Have a good one.
You too, guys. Bye.